Hey everybody, today we're going to be doing some Unit 2 review on quadratic equations. So let's get straight into it. So it says solve by factoring, okay, and we got to solve this. So before I want to do anything, all I'm going to do is I'm going to go into my calculator, and I'm going to type the left side of this equation. So anything left of the equal sign. So I'm going to type this as my y1, and then this as my y2. And all we're going to effectively do here, so we're just going to type this out. So 3x squared plus 3x minus 8 as my y1, x minus 10 as my y2. We hit graph. We find the points of intersection, and this will be the solutions to this entire equation. So it's like the desired answer that you're kind of going for. So you have a peace of mind before you go into factor. So what you should get here is 0.667 comma 1 when you find points of intersection. And we're just going to keep that in mind as we begin to solve this. So yeah, let's get straight into it. So first, before all, what I'm going to do is I'm going to move everything to one side. So you can either move the 3x squared plus 3x minus 8 over here. But what I'm going to do is I'm going to make the right side equal to 0. So I'm just going to subtract 8x and add 10. Subtract 8x and add 10. So I get 3x squared, and then negative 8 plus 3 gives us negative 5. And then negative 8 plus 10 gives us 2 equals 0. So now all we can do is we can just factor this. We're going to factor by decomp since we have a number in front of our x squared term. So we have 3x squared. So a times c. So two numbers that multiply to give us 6 and add to negative 5. So there's only two factors of 6. It's going to be 1 and 6 itself, and then 2 and 2 and 3. So in this case, what works is going to be negative 2 times negative 3, negative 2 plus negative 3. So we're going to split this middle term into exactly that. So we got negative 3x, negative 2x plus 2. And we're just going to group these two. And you're going to factor out what's common between them. So in this bracket, we have a 3x that's common. So 3x squared minus 3x, or divided by 3x is just going to give us x. That's going to give us 1. And then you're going to factor out a negative 2 here. And you get x minus 1. So now you're going to group this and this. And you should get 3x minus 2, x minus 1 is equal to 0. So now what we can do is we can individually set each bracket equal to 0. So 3x minus 2 equal to 0, x minus 1 equal to 0. And then we just isolate for x at this point. So we get x is equal to 1, and x is equal to, so we add 2 to both sides. Add 2 to both sides. Alright, add 2 to both sides here. And then you get 3x equals 2. And then you just divide by 3 and you get x is equal to 2 over 3. And you're going to notice earlier we got x is equal to 1 and 0.6667 whatever, right? So 2 over 3 is going to be 0.6600667 whatever. So we know our solutions are correct, and therefore we have done this correctly. So just give a double check mark there, and that's how you solve the first one by factoring. Alright, we're going to be doing one of these ones. So it says solve by factoring, and what you could do is you could technically expand all of these x minus 7 terms and just FOIL it, but we're not actually going to do that. We're going to be doing a plug-in method, which is going to be a lot faster. And yeah, so we're going to do is we're going to say any variable is equal to x minus 7 here. So let's say a equals x minus 7. And this is going to be important for later, so make sure you box this just for now. And we can plug in a for our x minus 7. So we have a squared plus 5a plus 6 is equal to 0. So now this is a lot more manageable, right? So we can just factor this normally. So we have two numbers that multiply to 6 and add to 5. So we have 2 times 3, 2 plus 3. So a plus 2 and a plus 3. Factoring by inspection there, of course. And now all we're going to do is we're going to set each individual term equal to 0. A plus 2 equals 0. And a plus 3 equals 0. You isolate for a, get a equals -2 and -3. And now what we're going to do is we're not done here. Since we set a variable equal to x minus 7, we now have what the variable is equal to. We have -2 and -3. So now we can move back to this original equation we put, which is a is equal to x minus 7. And since we got our values for a as -2, we're just going to plug them in. So we have -2 is equal to x minus 7. And we have -3 is equal to x minus 7. So now all we got to do is isolate for x. In this case, I'm going to add 7 to both sides. And that's going to give us x is equal to 4. And add 7 to both sides. And you're going to get x is equal to 5. So you should get that by doing the plug in method. And the way we actually check this is, again, we're going to use our calculator. We have this original equation here, which I'm going to outline in blue. We have this original equation, right? And what we can do with that is we can actually plug that into our calculator and see if we're right. So the left side of our equation here is going to be x minus 7 squared plus 5x minus 7 plus 6. And the right side is equal to 0. So now we're just going to wait for that. We can find our points of intersection. So we go second trace, intersect. And you get 4 and 5 as your answers, which is what matches up to our algebraic solving method. So we have done this correctly. Therefore, we're good. We're good. So let's move on. Alrighty, so we have our next set of problems here. So this time it says to solve by completing the square. Completing the square is good because it'll give us exact value solutions. So that's just one thing to note. So we can get straight into this. This first equation here is really nice because it's actually already isolated our c value, so we don't have to do anything here. So we can group these things up and give our a and our b. And to complete the square, we gotta divide our b value by 2. So if b equals 8, we're just gonna divide this by 2, and it gives us 4. And of course, we're gonna square that to give us 16. So we have x squared plus 8x plus 16 minus 16 is equal to 7. So we want to factorize this, but in order to do that, we have to actually remove this -16 by multiplying by what's in front of our x squared term. So -16 times 1 gives us x plus 8x plus 16. And then we have our -16 on the outside. So now we can actually group these boys up. And if you watched my last video, you know that when we divide our b value by 2, whatever we get, all we got to do is just put an x in front of it. So we have x plus 4 in this case, since we have a positive 4. minus 16 equals 7. So now what I'm going to do is I'm going to add 16 to both sides. Yeah, you add 16 to both sides, and you should get x plus 4 squared equals 23. You square root both sides, and you should get x plus 4 equals, remember when we're square rooting, we're going to take plus or minus, so we should have plus or minus root 23. And we're going to subtract the 4 out here. So we're going to get x is equal to negative 4 plus or minus root 23. And of course, if this radical is not a prime number, you're just going to you have to break it down, and then you can simplify it. But in this case, there's not anything we can do. So there's no point in breaking it down. Root 23 is going to be impossible to break down since it's a prime number, and we're just gonna have to leave it as such. So these should be your solutions. And the way you actually test this is by going in your calculator and plugging them in. So since our original equation was x squared plus 8x is equal to 7, and we got x is equal to negative 4 plus or minus root 23, what we're going to do in our calculator is we're going to type in negative 4 plus root 23 brackets, and then we're going to store this as x. We're going to go x squared plus 8x, and this should give us an output of 7. And since it does, our first solution is going to be correct, since left side equals right side whenever we plug in x. But since we have a second solution here, we need to test the negative portion of this. And the way we do this is we're just going to go up, type in the same thing, change the sign for a negative, but store it as x as well. And then you just type this equation out again, and it gives you 7 as well. So both equations, when plugged back into the original, or both answers when plugged back into the original, give us our answer of 7. So we are indeed correct. And just make sure you're simplifying the radical if possible, because you will lose points on that if it's a written response. But in this case, we don't have to, or we can't actually, so there's no need to worry about that. Alrighty, so we're going to solve by completing the square here. And we have 2x squared minus 20x plus 14. So this one is not going to be as nice because it's not simplified already, so, or not, So let's subtract 14 from both sides here to get our c value out of the way. So we have a, b, c. It's just, you could keep it there technically, but I like to get it out of the way so it saves an extra step at the end, as you'll see. So you have 2x squared minus 20x is equal to negative 14. Now, all we're going to do is we're going to put these in brackets, and we're going to factor out whatever's in front of the x squared term. So since we have 2 in front of the x squared term here, we're going to factor out a 2. So we're going to get x squared minus 20 divided by 2 is going to give us 10x is equal to negative 14. So from here, what we can do is we can complete the square. So we have x squared minus 10x, and this is going to be a, and this is going to be b. So b divided by 2 squared gives us our new c value, as you remember. So we're just going to take negative 10 divided by 2 and get negative 5 squared is equal to 25. So we have plus 25. And since we can't just add these random numbers into our equation, we have to actually subtract 25 at the end. And it's going to be all equal to negative 14. So all we need to do is we need to remove this 25 from the bracket here. So we're going to multiply by whatever's in front. So again, what's in front here is going to be negative, 2. So you're going to have negative 25 times 2 outside our bracket. So x squared minus 10x plus 25 minus 50, since we multiplied it by 2 to bring it out. And we have negative 14 at the end. So now we can actually factorize this. So as you remember, whatever we're dividing our b value by 2, all you have to do is you put an x in front of it, and that's how you factorize it. So we have x minus 5, since we got negative 5 when we divided it by 2, squared minus 50 is equal to negative 14. So what I'm going to do is I'm going to add 14 to the other side, and that's going to give me, so add 50 both sides, and that's going to give me 36. So we have 2x minus 5 squared equals 36. And I'm going to divide both sides by 2. And now what you're going to get is you're going to get x minus 5 squared equals 18. And now we can just square root both sides. And you get x minus 5 by itself equals plus or minus root of 18. And now we're just going to add 5 to both sides, and you get x is equal to 5 plus or minus the square root of 18. However, like I said, you're going to need to simplify what's inside of this radical here. So if we recall from Math 10C, we broke it down, right? We broke down the radical in our prime factors. So we have 18 is equal to 9 times 2, 3 times 3. So x equals 5 plus or minus square root 3 times 3 times 2. And since our square root is an index of 2, it's looking for groups of 2. So we're going to move that out front. And we're going to get x is equal to 5 plus or minus 3 root 2. And this is going to be our fully simplified version of the solution here. Now, again, like I said earlier, we can plug this into our calculator and we can test for if our solution is right. So we got 5 plus 3 root 2 as one of our solutions. So I'm going to put that all in a bracket. We're going to store it as x. And then we have our original equation, which is 2x squared plus, or 2x squared minus 20x plus 14. And when we plug that in, since our x is equal to one of our solutions, it gives us 0. 0 equals 0, meaning our solution is correct. You can test it out for the other one, but I'm just going to let you know it is correct as well. So that means we have solved algebraically correctly. So good job. We can move on now, I assume. Alright, so now we're going to solve by using quadratic formula. The way I'm going to actually try to do this is we need to have an a, b, and c value. So we're just going to subtract 8 here, and we're going to get 2x squared plus 5x minus 8 equals 0. And it's essential that our right side is going to be equal to 0, because if it doesn't work, quadratic formula doesn't work if it's not equal to 0. So if you recall, quadratic formula is going to be negative b plus or minus square root of b squared minus 4ac over 2a. So we're going to label it a, b, and c. And since our b is 5, we're just going to plug in all our values. So we have negative 5 plus or minus the square root. And then we have 5 squared minus 4 times 2 times negative 8. And then we're going to have this all over 2 times 2. So we can begin to simplify this now. So this multiplies onto here. So we get negative 5 plus or minus the square root of 25 minus, what is that, 4 times 2 times negative 8. So 4 times 2 times negative 8 gives us negative 64 all over 4. Now we can just do this. So 25 minus negative 64. That gives us root of 89. All over 4 is equal to x. So now that we have this, what we can do is we can begin to simplify the radical again. So 89. Okay, well in this case, 89 is actually a prime number here, so we can't simplify this any further. So this is going to be our final answer here. So if we plug in negative 5 plus root 89, or sorry, let's do alpha y, make it a fraction. So you have negative 5 plus root of 89 all over 4. And we're just going to store this as our variable x. So now we can go back into our original equation, which was 2x squared plus 5x. This should in turn give us 8, and it does, and the other solution is going to work as well, but I'm not going to test it, but it does work. But that's how you know your solutions are correct. So yeah, I mean, that's how you solve by using quadratic formula for this one. Quadratic formula is good as well, because it also gives you exact value answers, as well as complete the square. But I would say quadratic formula is easier to manage, and it's not like as tedious as completing the square in my opinion. So yeah, let's get straight into this one. So we have 5x squared minus 11x equals 6 plus 2x. So the way we can actually do this is we just subtract 2x and subtract 6 from both sides. So we get 5x squared, and then we have 11x minus 2x gives us negative 13x, and then minus 6 at the end there is equal to 0. Make sure it's equal to 0 for quad form, and we have negative b plus or minus square root b squared minus 4ac all over 2a. So our negative b here is going to be negative 13 plus or minus the square root of negative 13 squared minus 4 times 5 times negative 6 all over 2 times 5. Once you plug in all your variables, you can begin to simplify now. So you have the negative out front, so we just get 13 plus or minus the square root, and we have 13 squared. So you just put this all in your calculator, so 13 squared minus 4 times 5 times negative 6, and that gives you 289. And then 2 times 5 is going to give us 10. And we're going to be left with this. So I want to begin by trying to break down 289, right? So 289, maybe it's divisible by 3. No, maybe it's divisible by 6. Maybe it's divisible by 16. Alright, so in this case, we have the square root of 289. And if we take the square root of 289, that actually gives us a nice number. So we can just rewrite this as 17. And since there's nothing common between all of these numbers, we're going to have this equal to x. We can't simplify it any further. But if there was, we would just have to find the GCF. It's the greatest common factor of all the terms. Like, for example, if it was 4 plus or minus 2 root 2 over 2, for example, it would have a GCF of 2. So you would just divide everything by 2, and you would get 2 plus or minus the square root of 2 over 1, which is just this. So just make sure you're always double checking and trying to simplify these whenever you're getting exact value solutions. So with that being said, we can actually test out our answer now. So our original equation was 5x squared minus 11x equals 6 plus 2x. Okay. So let's just get our first answer as one of our solutions. So 13 plus 17 all over 10, which gives us x equals 3. And 13 minus 17 all over 10, which gives us negative 2 over 5. So now we can plug in our answers. So we store -2/5 as x, and we should get 5x squared minus 11x, which is the left side of our original equation. And that should give us 6 plus 2x, which is left side equals right side, meaning this solution is correct. Now we can actually test 3. So we have 5 times 3 squared minus 11 times 3. And that should equal 6 plus 2 times 3. And what do you know? Left side equals right side. So these two solutions are going to be correct. And of course, if you wanted to check by doing the left side and right side method in your calculator, just do this. 5x squared minus 11x equals 6 plus 2x. And they should have intersection points at 2 or at 3 and -2/5. So it's going to be 3 up here and -2/5 over here. And that's how you check with your calculator. So with that being said, that is how you do quadratic formula. Make sure you're simplifying, make sure you're checking for GCF, and just making sure that everything lines up. One thing to note is that if you get your discriminant as a negative number, it's going to give you no solutions, because there's going to be no real solutions to that equation. So just make sure whenever you're doing that and you're getting a negative number, make sure you're double checking it and ensuring that it's actually a no solution answer. And that will be a nice little segue into our next little topic here, which is going to be discriminant. So if we take a look at our quadratic formula, we have negative b plus or minus the square root of b squared minus 4ac all over 2a. What's inside of the square root will tell you how many solutions there actually are to an equation. So since we're taking the square root, it determines whether our solution is either a positive or b negative, in that case, which it will give you a imaginary number, or it's equal to 0, which will give you one solution. So just know that discriminant is equal to b squared minus 4ac, and this is something that they're going to use universally, and you're not going to get this on your formula sheet, so make sure you're memorizing that b squared minus 4ac is indeed the discriminant. So now we're going to actually learn how to apply this said rule, I guess. So for what values of k will produce two distinct roots? We'll do the first part of this. So if we're looking for two distinct roots, we're going to be looking for where this equation is greater than 0. Or, sorry, where our discriminant is going to be greater than 0. To have two distinct roots. So we're just going to plug in our value for a, b, and c. We have -4 squared minus 4 times 3 times our c value, which is k. So now you should get 16 minus 12k is greater than 0. You add 12k to both sides, you're going to get 16 is greater than 12k. And you divide both sides by 12 to isolate for k. You get 16 over 12, which just turns into 4 over 3. Meaning that k has to be less than 4 over 3. So alternatively, this could be written as k has to be less than 4 over 3. So what this means is our value of c has to be less than this number 4 over 3 to produce two distinct solutions. Now what we're going to do is we're going to do the second part of this. So if we have two equal roots, what that means is that our discriminant is going to be equal to 0. Because when we have a two equal roots, what that means is we're going to have a perfect square trinomial. So what that may look like is like x plus 3, x plus 3. And this is going to give you a perfect square trinomial where both solutions are equal. Meaning they have one solution overall, but they have two equal solutions. So it's like synonymous with kind of two equal and one solution are synonymous, interchangeable. So just make sure you're aware of that. So we're gonna set our discriminant equal to 0. Now all we gotta do is we just replace negative 4 squared minus 4 times 3 times k is equal to 0. And we get 16 minus 12k is equal to 0. 16 equals 12k. And you get k is equal to 4 over 3. So when k is exactly 4 over 3, that means we're going to have two equal solutions. Or in other words, one solution. So far we got two distinct roots and two equal roots. So now we just got to figure out what it'll look like if we have 0 real solutions. So we have b squared minus 4ac as our discriminant. And if it's 0 real solutions, that means our discriminant is going to be a negative number, which means it's going to be less than 0. Remember, this is all going to fall under the square root. If we're taking a square root of a negative number, that'll output imaginary solutions, okay? So let's do this. Just replace. We get negative 4 squared minus 4 times 3 times k. So this is going to be the same solution. We just get 16 minus 12k is less than 0. 16 is less than 12k. And we're going to get k is less than 4 over 3. You're going to notice for two distinct solutions, we had k is less than 4 over 3. For one solution or two equal solutions, we get k is equal to 4 over 3. And for 0 real solutions, we got k is less than, k is greater than 4 over 3, as seen here. And you can test it out in your calculator. So what is our original equation? We have 3x squared minus 4x plus, and we just got to put an input for k. So we said that if it was 4 over 3, that would give us one solution. So if we test this out, you can see that our vertex is our solution. Cool. So all we got to do now is just see if it was less than 4 over 3. So a number less than 4 over 3 would be negative 4 over 3, right? And we said that would give us two distinct solutions. And what do you know? We have two different solutions here. And now we can go back and we can test what values would give us 0 solutions. We said any number that's greater than 4 over 3. So let's say like 5 over 3. And what you're going to notice, it's not going to touch the x-axis at all, meaning we have 0 solutions. So that will be the answer to this. So you can always test what values and if your values are actually correct. Alright, so we're going to be applying this discriminant knowledge again onto this. So we have b squared minus 4ac. And we're looking for the values of k, which will give two real solutions. So if it's two real solutions, that means our discriminant is going to be greater than 0. So we're going to labels a, b, and c here. And we get our b value as negative k. So negative k squared minus 4 times our a value, which is 1, times our c value, which is 1, and that's going to be all greater than 0. So we get k squared minus 4 is greater than 0. So now we're going to add k to the, or add 4 to the other side, and we're just going to isolate for k by square rooting. And we're going to get k is greater than 4. However, when we're taking a square root of, when we're doing a square root, when we're doing inequalities, or sorry, this should be 2 here. K is greater than 2. When we're taking square root of an inequality, all we have to do is we're going to flip the sign here, and we're going to have a negative number. Because remember, when we're taking square roots, there's a plus or minus answer to it, right? So yeah, we just have our, 2, but we also have our negative 2 to account for. So if we flip the sign and account for the negative, we get k is, flip the sign, k is less than negative 2. So our shaded region will be where k is greater than 2, but k is less than negative 2. And I kind of want to display this with your calculator, and this is going to be more of a Unit 3 thing, but it's good to know because they're going to be asking you stuff like this. So we have k squared, or in this case, we're going to write x squared. So x squared minus 4. And since it's greater than 0, we're just going to say y is going to be less than. So you don't have to know how to do this. This is a visual. So basically, the shaded region where the inequality is true is where x is less than negative 2 and k is greater than k is greater than 2. Since it's a quadratic technically, since we have a k squared and not just a single k, it actually has 2 inequality solutions. So this will be one of them and this will be the other. I kind of want to give another example of that, so I will do that real quick. Alright, so this is going to be our second example of this. So we have our discriminant where we're going to be finding 2 solutions here. So we have b squared minus 4ac, and it's going to be greater than 0 since we're looking again for 2 real solutions. And we're going to get k squared minus 4 times 2 times 2. You get k squared minus 16 is greater than 0. So now with this, we're just going to add 16 to both sides, and you get k squared is greater than 16. So you take the square root, and we get k is greater than 4, but we need to account for the second solution here. So we're just going to do k is less than negative 4. And that's all you have to know. All you have to know is that you're just going to flip the sign and take the negative when it's a variable squared, since it's technically a quadratic. So yeah, I mean, as long as you know that, you should be fine. And yeah. Alright, so we have this word problem here, and it says right triangle has one side. So we're going to draw a right triangle. And one side that is 7 meters shorter than its shortest side. So let's say x is its shorter side, and one side that is 7 centimeters longer, so x plus 7. The triangle's hypotenuse is 8 centimeters longer than its shorter side, so we're going to get x plus 8 as our hypotenuse. So what are the dimensions of the triangle? So now that we've modeled our equation out, all we need to do is actually figure out how to do this. So as we know, Pythagorean theorem states that a squared plus b squared is equal to c squared. So in this case, we have a, b, and c. So all we need to do is plug it into our formula. So we have x squared plus x plus 7 squared is equal to x plus 8 squared. So now what we have to do is we're going to have to FOIL all of these individual brackets out. So we have x squared is on its own plus x plus 7, x plus 7 is equal to x plus 8, x plus 8. And effectively what we're going to do here is we're just going to FOIL. We're going to x squared plus x squared plus 7x plus 7x plus 49 is going to be our here. So we're going to collect our like terms here. So we're going to get 14x plus 49. This should be fun. And now we have the right side of our equation here, which is x plus 8, x plus 8. And we're just going to FOIL this here. So we get x squared plus 8x plus 8x plus 64. And now we just collect like terms here. And you're going to have plus 16x. And there's one more like term at the beginning of this equation here that we can collect. So we have 2x squared. And now we actually have a usable functioning equation that we can use. So what we do is we're going to move everything to one side. So you can move the left to the right or the right to the left. But in this case, I like moving everything to the left. So I'm just going to subtract x squared here. X squared. And those cancels out. And we should just be left with a 1 in front of the x squared. We have negative 16. So, no, we have 16x on the right side. So we're just going to subtract 16x on both sides. So 14 minus 16 gives us negative 2x. And we have minus 64 minus 64. And all we got to do is subtract 49 from 64. And that gives us negative 15. So now we're left with this single quadratic that we can factor and find what x is equal to. So again, we just do a times c. So we have two numbers that multiply to negative 15 and add to negative 2. So one thing to note is that our b value is a negative. So meaning the bigger factor of the two numbers is going to be negative. What I mean by that is since we have factors 3 and 5. Since we have negative 2 as a b value, our b value here is negative 2, there's a negative sign in front of it. The bigger number is going to be negative, so negative 5 is going to be the factor that's negative in this. But if that confuses you, just factor it normally. Negative 5 times 3 gives you negative 15, negative 5 plus 3 gives you negative 2. And you should get x minus 5, x plus 3. And now we can just solve for x, and we have x is equal to 5 and negative 3. But there's one thing to note, is we're going to have a reject solution here. Since we have one of our sides equal to a negative, we can't have a negative dimension. So we just have to reject this, or reject if this is our written response. And meaning our only solution here is going to be x is equal to 5. So the original triangle looked like this. So we had x plus 5, or sorry, x plus 7, and x plus 8. So we should, when we replace x, we should get is x equals 5, and then our original dimension is going to be 7 plus 5, which is going to be 12, and then this one should be 8 here. So x plus 8 gives us 13. So meaning our dimensions are going to be 12, 5, and our hypotenuse is going to be 13. Alrighty, so now we have turning our solutions into an equation. So if we have x equals negative 3, or x equals 3, and x equals negative 4 over 5, how do we turn this back into an equation? How do we make an equation with this effectively? So all we're going to do is we're going to try to make each side equal to 0. So I'm going to subtract 3 on both sides. You're going to get x minus 3 as one of your factors. And then if x is equal to negative 4 over 5 here, what I'm going to do is I'm going to multiply both sides by 5 to cancel out this denominator here. And you're going to get 5x is equal to negative 4. All you have to do now is add 4 to both sides, and you get 5x plus 4 as your other bracket. So now all this is going to be a matter of foiling. So we're just going to FOIL this out, and we're going to get 5x squared plus 4x minus 15x minus 12 as our final answer. So we just collect our like terms, and we're going to get minus 11x minus 12 as our final answer here. So that's the way we actually turn our roots into an equation. So I want to try this again. We'll do another example. For instance, if we have our solutions as x equals 2 and x equals negative 2 over 5. So what we're going to do is we're going to try to get one side equal to 0. So we have x minus 2 on this side, and then multiply both sides by 5 to cancel out this denominator. And you get 5x equals negative 2. 5x plus 2 as your other solution. So now these are your two brackets. All you have to do is you have to FOIL this out. Get 5x squared plus 2x minus 10x minus 4. And what you're going to get is 5x squared minus 8x minus 4 is your final answer. So it's very simple. All you're doing is just isolating, making one side equal to 0. So in this case, we have 2x or 5x minus 2 is equal to 0. Or 5x plus 2 is equal to 0. And then x minus 2 is equal to 0. So you're just doing the opposite. And this is just applying what you kind of know and then foiling it. Alright, so we're going to be doing this word problem here. We have a public green space measures 100 by 250. So it gives us two lengths. So we can assume this is a square or a rectangle. We're going to have 100 meters by 250 meters. A sidewalk is to be built along the edge of the park. So the edge is going to be these four. And if it reduces, and it says it reduces the area of the green space by 5%. So that means our inner green space is going to get smaller. So it's going to look like this once we build a sidewalk all around. And if we're reducing the green space by 5%, that means our original area is going to be 5% less. So our original area is just length times width. So we have our original length as 250 and our original width as 100. So when we multiply them together, we're going to get 25,000 as our original area. And since we have 5% reduced, what we can write this as is we can write 95%. So as a fraction, 0.95 times 2500. Since we're removing 5%, 0.95 is going to be that 5% removed. So we're going to have 0.95 times 2500. And that's going to give us 2375. Alright, 23750 as our new area. Additionally, you could also multiply our original area by 0.05 to represent the 5%, and then subtract that from 2500. But this is just a method so that you save time. So you write 95% since we're subtracting that 5%. Okay, so once we found the new area of our green space, all we need to do is write an expression that actually models this equation. So since our new length, we have a sidewalk being built around right? So the way we can represent this is we're just going to draw a line on each of the sides of the new box. And we're going to label this x. And x is going to equal the width of the sidewalk. So width of sidewalk is equal to x. So basically what we're saying is that our original box minus the width of the sidewalk is going to give us our new area. So the way we model this is we have length times width is equal to our new area. So we have 3750. And on this side, we're going to have our length, which was originally 100. And then we have our other side, which was 250. And since we're getting smaller, we're going to subtract. And we're subtracting the width, right? So we have a length up here, or we have width up here, and a width up here. So meaning that we have two x's that we're subtracting by. We have this x, and we have this x, which we're subtracting by. So we have 100 minus x, or sorry, 100 minus 2x, since there's two sides. And we have 250 minus 2x, since there's two sides. And what this represents is our new length times our new width, which gives us our new area. Basically, 2 times the width of the sidewalk, since we have this width of the sidewalk here, 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 subtracted by our lengths to give us our new area. So now we have a quadratic equation that actually models the solution, or models the situation. So the way we actually solve this now is we can begin by foiling. So you're going to get 2500 minus 200x minus 500x plus 4x squared is equal to 23,750. So now I'm just going to collect like terms. And you're going to get this. So now we have this equation here. All we can do is just make our left side, our right side equal to 0 by subtracting 23,750. And you should get 1250 minus 700x plus 4x squared is equal to 0. So now there's a couple ways you can solve this quadratic, but the way I'm going to use is quadratic formula, since factoring doesn't make sense, and completing the square would be a bit tedious here. So I'm going to label this A, this B, and this C. And we have 700, or negative 700, plus or minus the square root of negative 700 squared minus 4 times 4 times 1250 all over 2 times our A value, which is going to be 4. So now you can plug this all in your calculator. So we have 700 plus alpha y, the square root, negative 700 squared minus 4 times 1250 all over 8. Sorry guys, you should include the 700 in the fraction here. So 700 plus the square root of bracket negative 700 squared minus 4 times 1250 all over our 8, which gives us 173.1956. as our first solution, and our second solution as, so let's just change the sign for a negative. (1.8). So there are two solutions to this equation, but since if we're subtracting, we have 100 minus 2x. If we're putting in 173, that would give us a number bigger, and it would be negative because we're subtracting 2 times whatever this number is. So it would give us a negative output. And it's just such a big number that it exceeds the dimensions of this square. So this is going to be a reject solution. Whereas 1.8, 2 times 1.8 looks actually manageable. And 250 minus 2 times 1.8 equals our new area. So now we can actually test out if we got the right answer. So if we plug 1.8 back into our original solution, our original equation, which was this right here, it should give us our new area, which is going to be 23,750. So let's do this. So we have 100. So 100 minus 2 times 1.8 bracket 250 minus 2 times 1.8, and it gives us 23750. And since this is like rounded, we round it up. It's not going to be exact, but more or less the same in this case. So we can say our x is equal to 1.8. And you can find the individual new dimensions by just remember that this is length and this is width. So if we were just asked for length individually, we just do 100 minus 2 times 1.8, and whatever that is going to be our new length. So we have 100 minus 2 times 1.8. It's going to be 96.4. And then our new width, since it's 250 minus 2 times 1.8, should give us 246.4. And when multiplied together, this should give you the new area. So this would be your length and your new width. And in terms of finding the width of the sidewalk, x is equal to the width, and the width of the sidewalk would be 1.8. So that means this all across would be 1.8, meaning we have solved this problem. Sorry, it's a bit of a mess, but basically, as long as you followed all the steps, you should be fine. Alright, so here's another problem that we have. We have determined the nature of the roots. So in order to determine the nature of our roots here, what we're going to have to do is we're going to have to look for how many solutions with that Alright, so we have a question asking us to determine the nature of the roots. To determine the nature of the roots, all that means is we're just going to be looking for how many solutions this given equation has. So if you recall, our discriminant actually determines how many solutions a solution has. So our given equation has. So if we just replace our numbers in our discriminant here, so we have 1 times 4. So we get 49 minus 16 equals 0. Or sorry. And then we get 36 as our discriminant. If our number is positive when we plug in our discriminant, that means we have 2 solutions. So in this case, we have 2 solutions. I'm going to give another example just to test this out, just for you guys to test this out. Alright, so here we have 4x squared plus 12x equals -9. So the way we do this is we're going to move 9 to the other side. We get 4x squared plus 12x plus 9 is equal to 0. And we're just going to, again, put in our discriminant. So we have 12 squared minus 4 times 4 times 9. And that's going to give us 144 minus 144, which is equal to 0. And if we're getting our discriminant a 0, that means we have one solution. So the nature of the roots is one solution. However, if this number were negative, that means we would have no solutions. So just keep that in mind, and whenever you're asked to find the nature of the roots, this is all you have to do. You have to use your discriminant formula. Alright, so here we have a quadratic that we need to solve. So all we're going to do here is we're going to multiply by 2 to cancel our denominator. And we're going to get x plus 1 squared minus 7 is equal to 18. We're going to now add 7 to both sides. And you're going to get 25. You're going to take the square root, and you're going to get x plus 1 equals plus or minus square root of 25 is equal to 5. And now we're just going to subtract 1, so we have x is equal to negative 1 plus or minus 5. So negative 1 plus 5 is going to give us 4. Negative 1 plus 5 is going to give us 4. And negative 5, our negative 1 minus 5 is going to give us negative 6. So we're going to have 4 and negative 6 as our solutions here. So there's no need to actually expand this bracket out and FOIL, because that's going to be more of a tedious process than actually just, keeping it as it is. So just make sure you're doing that. Alright, here's another problem we have. We have x squared minus 5x is equal to 0. So there's a couple ways we can do this, but the easiest is going to be solved by factoring. So what's common between these two is an x, so we can just factor out an x. We're going to get x minus 5 is equal to 0. Now we're going to set each term equal to 0. So we're going to have x equal to 0, and then we have x minus 5 equal to 0. At 5, and we get x is equal to 5. So our solutions here are going to be 0, 0, 5. It's a very simple one there. And now we have this one. So we have 16x squared minus 25 is equal to 0. So what we can do here is we're going to notice we have all perfect squares. We have 16 is the perfect square. We have x, which is squared, and we have 25, which is a perfect square. And since it's being separated by a minus sign, make sure you're acknowledging that it's a minus sign, because difference of squares does not work if it's not being subtracted. It has to be an actual difference. So the way we do this is we're going to square root both sides. And remember that a squared plus b squared is equal to a plus b times a minus b. So all we have here is we have 4x plus 5 and 4x minus 5. So now we have 4x plus 5 is equal to 0. Subtract 5. 4x equals negative 5. X equals negative 5 over 4. But x equals plus or minus 5 over 4. Because if you did this, someone will give you positive 5 over 4, so we can just rewrite it as x is equal to plus or minus 5 over 4. And that's how you solve by using difference of squares. Alrighty, we have this word problem here. When a football is kicked, its height can be modeled by the function h of d is equal to negative 0.8 d squared plus 4.8d minus 2, where d is the horizontal distance traveled in meters, and h is the height of the ball in meters. So we have this where d and h, and we're just looking for the horizontal distance that the ball travels. So let's just calculate the horizontal distance here. So let's do this. So if we go in our calculator, we're going to plug in our equation here. So we have negative 0.8 x squared plus 4.8 x minus 2 as our equation. Sorry, let me just reset my zoom settings here. And we're just looking for the horizontal distance. But there's one thing to know. Since our graph doesn't start, or our distance of the ball doesn't start exactly at 0, 0, right? Like the line doesn't start at 0, 0 like my depicted image does. We actually have to account for the fact. And the way we do so is we actually have to subtract the second solution, so the farthest one, by the nearest to get the distance between the 2 points. So effectively all we're doing is we're just looking from the distance from one x-intercept to another to find the horizontal distance of the ball. So with that in mind, all we have to do is we actually have to solve for x. So the way I'm going to do this is, since this is a word equation, you could use, and it doesn't state what to use, you can actually solve this using your calculator. So if you set the right side equal to 0, and you find the intersection points, you get 0.45. So I'm going to write 0.45049 as our first x-intercept, and our second one is going to be equal to 5.54 95089, whatever. Okay, what we have to do is we have to subtract our bigger distance by our smaller distance. So since we have our parabola that looks like this, we just have to find the distance between these 2 points to find the distance that the ball travels. Because technically, if we just put our bigger distance as our answer, it wouldn't be true, because that would be saying that this distance from here to here is the distance of the ball, when realistically, we're looking at the equation that models where the ball's traveled, and the distance is only going to be from one x-intercept to the other. So we're going to do 5.54 950 minus 0.450. So if we do this, we have 5.5495 minus 0.5 or 0.45049, and this is going to give us 5.09 as our final answer here. So wait, 5.09, and since we're rounding to the nearest tenth, we're going to 5.1 meters as your final answer here. And this is going to be applicable to any sort of question where you plug in the equation that the equation models, and since it doesn't start at 0, 0, you actually have to subtract the points to get the horizontal distance. So just make sure you're accounting for the fact, and you should be fine. Okay guys, this is going to be our last question here. We're just going to be doing a last factoring one, so let me get that all ready. Alright, so we're asked to solve this equation by factoring. So if you remember from 10C, whenever we're factoring, the first thing we're going to look for is a greatest common factor. So since we have a greatest common factor here of what looks to be 6, we can actually divide our whole entire equation by 6. So we have this, cancels out, and we're going to get x plus 2 squared plus 4 x plus 2 plus our plus 3 when you divide everything by 6. So now that we've divided everything by 6, we can actually recall from earlier that you could technically factor or expand all of these, like do FOIL or whatever, solve, but that is going to take a lot of time. So what we can do, we can set a letter equal to x plus 2. So we have a is equal to x plus 2. And now we just plug in a for x plus 2. So we have a squared plus 4a plus 3 And now we can just factor. So we have a AC, so we have a 1, so two numbers that multiply to 3 and add to 4. So we have 1 and 3 and 1 and 3. So we get a plus 1, a plus 3 is equal to 0. Again, all we have to do is individually set each factor equal to 0. So we have a plus 1 is equal to 0, and a plus 3 is equal to 0. Now we just subtract 1 from both sides, and we get a is equal to -1, and a is equal to -3. So now from here, what we're going to do is we're actually going to plug our value of a back into here, because we're not done. Remember that we set a equal to x plus 2. Now that we actually found what a is equal to, we can just plug it back in. So we have a as -1 is equal to x plus 2. And we solve minus 2, and we get our x is equal to -3 as one of our solutions. And our other solution should be a is -3 equals x plus 2. And we subtract 2 from both sides. We get -5 is equal to x. So we should have -5 and -3 as our final solutions here. And that is how you solve this by factor. Alright everybody, that is going to be it, and I really hope this video helped. And if it did, just let me know. If you have any questions, as usual, just leave them in the comments. Always be here to help. Yeah, and good luck to everybody. Hope you guys do well. Thank you for watching.